In today's lesson, we're going to be looking at the rates between different units of measurement to be able to convert between one unit of measurement to another. The lesson summary reads, conversion tables contain ratios that can be used to convert units of length, weight, or capacity. You must multiply the given number by the ratio that compares the two units. We're going to look at an example. If we're going from, in the first problem, 4 feet, to find out how many inches, what I want you to first do is set up your ratio table showing the relationship between the two units. We're looking at feet to inches. That relationship says that in 1 foot we have 12 inches. So to get to 4 feet, we're multiplying by 4. Whatever you do to one side, you must do to the rest. And we have 48 inches. The other side, now we're comparing yards to feet. And in 1 yard, we have 3 feet. So 3 feet is 1 yard. So if we have 50 yards, that means we're multiplying by 50. And that would give us 150 feet. To go from ounces to quarts, the ratio table is there are 32 ounces in 1 quart. So to get to 256 ounces, we're going to be multiplying by 8. 32 times 8 is 256, and that is 8 quarts. Solve these problems. Make sure you show your ratio table between the two units. And then just figure out which side you're manipulating to get to the target. For some more difficult problems that aren't so straightforward in terms of just converting these ratio units, we're going to look at a problem like this, and I'm going to take you through a strategy that you can use, especially because you don't have a lot of background thus far in dealing with fractions. The problem reads, Mr. Guzman has a piece of wood that is 1/3 meters long. If he cuts the wood into 5 equal pieces, what is the length of each piece? Let's start out by drawing a visual model of this. So if I'm calling this whole thing, or this unit bar, a meter. So from here, from this side to this side, is 1 meter. Mr. Guzman has a piece of wood that is 1/3 of a meter. I want to visualize this as to now kind of see it. Now he's taking that 1/3 of a meter. I'm going to actually switch where I wrote this. He's taking that 1/3 of a meter. This is 1/3. And he's cutting it now into 5 equal pieces. What is the length of each piece? So it's asking, what is the length of this one piece right here? And one way you could solve it is to start thinking about this in terms of a fractional model. And to do this, you have to think, okay, if I'm taking this 1/3 and cutting it into 5 equal pieces, then I must do the same to this 1/3, because whatever I do to one part, I must do to the rest. So you would take this part and cut it into 5 pieces as well. So I had 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5 parts. And I would do the same thing over here. 1, 2, 3. Okay, so now you can really clearly see that my total parts increased from 3 parts to 15 parts, and I have 1/15 shaded. Another way to think about this is more just going through the actual concept step by step. If I have 1/3 of a meter, I'm now dividing my 1/3 by 5. It's hard to take a fraction and divide by a whole number. So instead of calling this just 5, I'm going to refer to this as a fraction because every number is a fraction. So as a fraction, it's really 5 over 1. Now let's just divide each side across. And look what happens. 1 divided by 5. We're working with fractions, so I don't want you to go down and actually turn this into a decimal place. Call it 0.2. No, we're not going to do that because I don't want to mix my decimals with the fractions on this problem. So 1 divided by 5, I'm simply going to call 1 divided by 5, 1/5. My 3 divided by 1, well, that's pretty simple. 3 divided by 1 is 3. And therein lies my answer, 1/5 thirds. Wait a minute. That looks kind of funny. Well, let's break up what this means. It's saying 1 divided by 5 divided by 3. Let's do that. 1 divided by 5 divided by 3 equals 1 divided by 15. If I'm dividing it by 5 and then dividing it by 3, it's like dividing it by 15. And it's the same thing as I did up here, except in this visual model, I first divided it by 3, and then I divided it by 5. But now I'm saying I'm dividing it by 5 and then by 3. It's 1/15. Let's do the next problem to see if you can get a better concept of it. Oops. I knew I had another problem there. Okay, we did Mr. Guzman. Let's try Mr. Wilson. Mr. Wilson has a piece of rope that is 3/4 meters long. Try to work on this one with me here. If we have a meter, I'm just going to draw out what we have. Let's call this whole thing as a meter. And he has a piece of rope that's 3/4 of a meter. I don't like the way I drew that. Sometimes you gotta erase. All right, I like that a little better. He has a piece of rope that's 3/4 of a meter long. So this time, his is that long. That piece of rope is 3/4 of a meter. If he cuts the rope into 2 equal pieces, what is the length of each piece? You see this one might be a little trickier because now we're dividing it just into 2 parts. And that's kind of difficult now to get the visual on. So that's why it's good to have a bag full of strategies. Because what I'm saying is that if I'm taking 3/4 and I'm dividing it by 2, I'm going to call that 2 over 1. What I have is 3 divided by 2, 3 halves, and 4 divided by 1 is 4. Well, what does this tell us? Wait a minute. 3 divided by 2 divided by 4 is telling us it's taking 3 and it's dividing it by 8. And now if we can get a visual of what that looks like, you can see if you can look at these bars to see how now we're actually taking these 3 parts and cutting it into 8. That's where the difficulty comes in, which is why I want you to have more than just one strategy here.